anti-tail just did something that shouldn't be physically possible for natural comets. It reversed direction relative to Atlas's motion, and the new Hubble image proves it with extraordinary clarity. November 30th, 2025. Hubble Space Telescope captures Atlas with remarkable 0.04 arcsecond resolution. And when scientists apply rotational gradient mapping to enhance the structure, they find clear evidence for two jets with an anti-tail extending more than 60,000 kilometers directly toward the Sun. That's 10 times Earth's radius, pointing in the direction that radiation pressure should be preventing material from traveling. But here's what makes this genuinely extraordinary. Back on July 21st, when Atlas was approaching the Sun before perihelion, Hubble captured an anti-tail pointing toward the Sun. Now on November 30th, as Atlas moves away from the Sun after perihelion, the anti-tail still points toward the Sun. During the perihelion passage, the anti-tail apparently reversed its direction relative to Atlas's steady motion through space. It appears to always point toward the Sun, irrespective of which direction Atlas is actually traveling. Think about what that means physically. Normal comet tails follow simple rules dictated by radiation pressure and solar wind. Material gets pushed away from the Sun, creating tails that point in the anti-solar direction. The tail always streams behind the comet as it moves, blown backward by the Sun's energy. But Atlas's anti-tail doesn't follow these rules. It maintains orientation toward the Sun, whether Atlas is approaching or receding, as if it's locked onto the solar direction independent of Atlas's velocity vector. This phenomenon is not normal in familiar comets and demands explanation. When observations contradict everything we understand about how cometary material should behave under solar radiation, we're either witnessing physics we don't understand, or we're looking at something that isn't following natural comet behavior patterns. As Loeb writes, the foundation of science is the humility to learn, not the arrogance of expertise. And right now, these observations are teaching us that Atlas doesn't behave like anything in our experience with solar system comets. Amateur astronomers continue capturing this structure at scales stretching millions of kilometers, with multiple jets visible in images from observatories worldwide. Michael Yeager and Gerald Rayman captured Atlas on November 28th, showing the anti-tail configuration clearly visible. The Canadian Space Agency's orbiting telescope photographed the jets on December 2nd, with a field of view spanning 250 by 190 million kilometers, revealing structure that extends across distances larger than the Earth-Sun separation. Multiple independent observers, using different instruments and processing techniques, are all seeing the same phenomenon, confirming this isn't artifact or error, but genuine structure that requires explanation. The anti-tail always points toward the Sun, before perihelion, after perihelion, through the entire journey. That's not how radiation pressure works. That's not how solar wind behaves. That's not what natural sublimation produces. Something about Atlas maintains this geometry against the forces that shape every other comet we've ever observed. And until we understand what mechanism allows material to point sunward with such consistency, we're left with observations that challenge our models of how these objects should behave. Follow right now so you don't miss any information.